go and create a new part file. Okay, so yeah, I hope everyone here are familiar with the sketching part and the 3D model. Just lay the basics now, and we'll start build upon it. Okay, so we'll be building upon it. So first, let me take the front plane and do some basic sketch. Good, good. For extrude, you know, obviously you would have used it many times by now. So we'll make a simple cube or rectangle, whatever it may be. Okay. Now we'll like hope it is clear that we have covered these two features in material addition, and in material normal we have covered these two things. Okay. Okay. Now let us take this case. Okay. So let's say your dimension is some 6 mm. So 6 mm means what you call this? Whether it is a sheet or a plate. What is the basic definition? I think some limit is there. No? Below this thickness, it is called as a sheet metal. After this, it will be called as plate. I think it is 6 mm. If I'm right, good. So let us take this plate of 80 plus 80 and 6 mm thickness. Okay. So in this plate, I need to mount. Okay, I need to mount to some other thing. Okay. So how the mounting or fastening will be done? By means of fasteners, right? Standard fasteners. So the standard, see, if you are making some large assembly, you won't be doing the fasteners and all. See, the threads, the head, and the sockets, those dimensions, those designs, you won't be doing. Then from where we'll take that? Of course, we have a predefined database or toolbox available in SolidWorks. Okay. So that will cater to the need of those standard fasteners. So if fasteners are standard, then the counterpart, the holes, okay, or the internal, let's say fasteners will be having the external thread and the internal thread, the tappings, those should also be standard. The type of hole should be appropriate for the type of fastener that you are going to use, right? So for making that holes, we should not be using the standard extruded cut, because extruded cut will just create a cylindrical cut, okay, just a cylindrical cut. It will not create that tapping, okay. But yeah, in this point, we have to clear two things. Making the tapping, or tapping in the sense what? Thread, that internal thread. Let's say if this is a plate, so if this is a plate, if you want to make, let's say, I will practically do it, then you'll understand. I want to do some M10 like socket for, not socket, hole for M10 for mounting an M10 bolt. Okay. So now I'll make like this. Okay. So this is 10 mm diameter, and I'll just go to feature, go to extrude cut it. Okay. Right. So I have made a hole like this, just a hole. Okay. You can say M10 can fit here also. Okay. But it will not be having any thread or something. It is just a cylindrical cut hole. If you want to have the representation of thread in the design itself, okay, there is one way of making it, cosmetic threads. So where you will be getting the representation of the thread also. Thread means what? It will have that extruded material, like it will have the major dia, minor dia, and pitch circle diameter, and it will have the helical angle, and it will create that threads. Obviously, that is what thread is, right? So that can be done. This is type 1, and in the other way, we can just make the cutout with the maximum dimension or the nominal diameter of the hole by using hole wizard. But it will not in practical. If you are seeing, see, now we are seeing this, right? While in physical sense it will not be like that, but when you convert this part to a drawing, then it will mention in an appropriate way how it should be mentioned in a machine drawing. See, in your engineering curriculum, you would have studied engineering graphics and this machine drawings and all, right? So in that, if you are a mechanical engineer, so okay, so you'll be studying how to represent a hole, how to represent a internal tapping thread, how to represent threads, bolts. So those things, the representations you'll be studying, right? Why those representations are there? Those representations are there to communicate your 2D drawing to the manufacturer. Okay, so a manufacturer won't require a physical thread here. Okay, because for making a thread, what are all the things? What are all the settings that he has to input in the lathe machine or in the CNC? Okay, he knows that. Okay, so he just wants a representation. So those representations that can be done by using hole wizard. Okay, so yeah, you will be knowing the difference when I actually do it. Okay, so now we'll make an M10 hole, a straight tap hole here in this plate. Okay, so for making that, you need not do anything here. You just directly go to hole wizard. No need to do any sketch and all. Directly go to hole wizard, which is available here. So here you can select the type of hole. Okay, hole specification you need to do. So what are all the types is there? See, this counter bore for fixing the hex head. This is countersink for using a CSK bolt, and this is a double pin hole, normal hole, and then this is a straight tap hole. Like if it is having a hole with an internal tap, so this is a straight tap hole. So many things there. Taper tap. What is this one? This is counter bore slot. So based on your application, based on what fastener you are going to use, you have to do this. Most frequently used thing is these 4 things. Okay. So now we'll make a straight tap. Okay, straight tap is a hole with internal thread. Okay, so once you select straight tap, if you scroll down, it will be asking you the standard. So in what standard I need to make? Yeah, ISO is preferred. Okay, like if you are going with other standards like JIS and all, which is frequently used, so you can go there. So for a hole and then and all, directly go to hole wizard, which is available here. So here you can select the type of hole. Okay, hole specification you need to do. So what are all the types is there? See, this counter bore for fixing the hex head. This is countersink for using a CSK bolt, and this is a double pin hole, normal hole, and then this is a straight tap hole. Like if it is having a hole with an internal tap, so this is a straight tap hole. So many things there. Taper tap. What is this one? This is counter bore slot. So based on your application, based on what fastener you are going to use, you have to do this. Most frequently used thing is these four things. Okay. So shaft there, and then tab the hole only. And based on what fastener you are going to use, you have to do this. Most frequently used thing is these four things. Okay. So now we'll make a straight tab. Okay, straight tab is a hole with internal thread. Okay, so once you select straight tab, if you scroll down, you will be it will be asking you the standard. So in what standard I need to make? Yeah, ISO is preferred. Okay, like if you are going with other standards like JIS and all, which is frequently used, so you can go there. So for now we'll choose ISO standard, and type you have to select bottoming tapped hole, straight pipe tap hole, or tapped hole. So these types we have to select. Okay, now we'll select tapped hole only. I'll tell the difference. Okay, first we will make the tapped hole. Now you have to select the size. So M5, the standard things will be there. So I'll select M10. So this is ISO standards. So it covers mostly everything, right? So what is this into M10 cross 1.25? That means what? 1.25 is the pitch. Okay. So you have to select the standard pitch. So based on what pitch the hole is made, you have to use the fastener. Okay. So you cannot use a 1 mm pitch hole with a 1.5 mm pitch or 1.25 mm pitch fastener, right? That will also damage the thread. So you have to be careful when it comes to the mating. Okay. So I'll select this 1.25 mm pitch, and this is the end condition. So whether it need to be a blind hole or a through hole. Okay, I'll select it's a through hole. So for the entire dimension thickness of this plate, the tap will be there. And then what else is there? Yeah, thread also true all. See, you can control the depth of the hole and the thread depth. Okay. See, you can make a hole. Let's say you have a plate of 100 mm thickness. In that, if your hole depth is 80 mm, you can still have 60 mm thread only, because your engagement till that is enough. Making a thread till 80 mm is not required. It's in some cases, in some loading condition, if it is that is not required, then you can go with that. Okay. So now I have selected through all only. After selecting all those things, go to position. Once you go to position, you select in which surface you want to lay that hole. I select it. Now you will get this preview. So based on that, you select the hole. If you want to position this hole somewhere between here and this plate, go to smart dimension directly, select the edge, select this. Let's say I want it from 10 mm from here and 10 mm from there. So I'll position this hole and give OK. Give OK. Now you can see you can see the representation also. See, in machine design, if you see this kind of representation is there, it means there is a tapped hole. Okay, but it will not actually show you this thing. Thread is not there, but this this particular 3D model, when it is drafted in a drawing, okay, it will give you that representation. It will give you that call out also. See, you can see that if you just go to edit feature, in the bottom you can see, yeah, so with thread callout. So that means it has that callout option. Callout in the sense when you are doing drawing, from this feature you can call out the dimensions. Okay. So like that you can do the holes. So this is one method. Here in using hole wizard, you can do some other things also, like let's say countersink CSK. CSK, if you want to do, here you have to select which standard. Okay, let it be ISO, and type hex socket header. So if you want hex socket CSK, then select this M10. If it is normal, condition is true all. So then go to position, then select this, and wherever you want, you can select this. See, you can see this is a CSK portion. It will be created like this. You can see this. So yeah, whenever you are mounting M10 CSK bolt, it will perfectly butt with this surface, and no other undulations of this fasteners will be there. Okay. So like this, we have to do it, right? And okay, since we are dealing with hole wizard now, so this is how you'll deal with hole wizard for creating standard holes. Okay, so try to use this as much as possible whenever it is not a hole for some other purpose, like for hanging or hooking or some other purpose. If it is a hole for fasteners, then you have to use this hole wizard option. Okay. Then I'll show you where the standard toolbars is there. I said, right, there are some standards for fasteners where we can take it and directly use it. And of course, for gears also there are some standards because those are all defined parameters. Like, see, in a standards per gear, everything is defined, right? So there is no need to make that gear from scratch, like making a hollow disc, circular disc, and generating that profile. See, and then giving the angle, the teeth, and all those things. It is hectic. So for that also, we have some standard toolbox. But for now, we'll just explore where the fasteners toolbox is. So if you see in the rightmost corner of the window, you will be having this palette. So inside that palette, okay, just go to design library. In design library, you will find toolbox. I think in some version, it will not be there. Just a second, guys. 1 second. 1 second. And here you can select which standard you want. Okay. So here you can select which standard you want. IAS, ISO. Okay, and symmetric. So you will select metric threads if you want metric threads. Usually you'll be using asymmetric. So inside asymmetric, what you will be having here, you want bolts and screw, right? So go to bolts and screws. You want a CSK head, right? The socket head is there. Where CSK is there? Yeah. So you go to machine screws, and inside machine screws, here you will be having. If CSK is not there, wait. Head socket heads. Hex head, socket head, set screws. Oh, this is grub screws. We want. Okay, we'll first bid for this one. Okay, so if we'll first take a hex screw, and if you take the screw, yes. But here we are in the part window, right? So I'll just show you how to take this. Basically, we'll do these things in an assembly, okay? Because see, this is one part, and this fastener is another one standard part. Okay, you can insert it inside a part also, so it will be acting as a derived part. Okay, but if you are doing it in the assembly, then you have other features also. So now here you see it is trying to get assembled over here. Okay, you see, if you take it near this hole, yeah, you keep it and click OK. See, this is making a derived part. Okay, so that is why this error is coming. Okay, since we are doing it inside the part itself. So like this, how this diameter is fixed now? See, that is guessed because based on the hole size that we are referring to. If this hole is, let's say, some smaller one, let us make some smaller hole here. Some M2, M4, okay, 4 mm. And if I'm extruding it, okay, now if I am going to the toolbox, okay, sorry, this is yeah, design library. If I'm making the same thing here, sorry, not here, here. If I'm taking and going near this small hole, it will generate the hole for this size. Sorry, why it is not happening? Usually it will ask. Since we have already used, it is taking that settings. We'll use some other thing. Okay. Yeah, you can edit this thing also. This mate alignment, everything will be there. You can change this also, but basically we'll do this in assembly. Okay, so this I have taken just to show how it is, how it can be done. Okay, So in assembly, you will be having this option to edit the diameter also. Okay. So now you can change this to M4, M5 or M6, whatever it may be. And this mate also you will be giving in assembly. Okay. So this is the thing. Now what I will do, we'll just delete this. So this option is done. So whole wizard we have done. Now we will go to these important features. Okay. Of course, these things are also important. We'll just cover it later. We'll first finish these things and we'll come to that. No, I don't want these things. I'll delete it.